Why do anteaters have no teeth at all? Imagine meeting a mammal that has no teeth, not even one. Now imagine that same animal eating up to 30,000 ants and termites in a single day. It sounds impossible. Teeth are one of the defining features of mammals, so how could an animal survive without them? And even stranger, why would evolution get rid of them in the first place? At first glance, an anteater almost seems unfinished. Its mouth is just a long, narrow tube with no rows of sharp teeth, no flat molars for grinding, and hardly any room to chew. If you compared its skull with that of a wolf or even a human, it would look strangely empty. So the obvious explanation might be that anteaters never evolved teeth to begin with. But that's not true. In fact, the story is far more surprising. Long before an anteater is born, something unexpected happens inside the embryo. Tiny tooth buds, also called tooth germs, begin to form, just as they do in many other mammals. For a brief moment, it's as if the animal is preparing to grow a full set of teeth. Then the process simply stops. Those early tooth structures disappear before birth, leaving every living anteater completely toothless as an adult. That discovery changed how scientists thought about these remarkable animals. Anteaters didn't start out without teeth. Their ancestors had them. Even today, their embryos still carry echoes of that ancient past. So, why would evolution begin building teeth only to erase them in the first place? The answer starts with what anteaters actually eat. Unlike predators chasing large prey or herbivores chewing tough plants, anteaters specialize almost entirely in ants and termites. These insects are tiny, abundant, and packed inside nests that few other animals can access. Finding them isn't the hard part. Getting to them is. Instead of powerful jaws, anteaters evolved something much more useful: enormous curved claws. They rip open termite mounds and ant nests with surprising speed, exposing thousands of insects in seconds. But breaking open the nest is only half the job. Now they have to collect dinner before the angry insects fight back. This is one of the most extraordinary feeding tools in the animal kingdom comes into play. An adult giant anteater can extend its tongue to around 60 centimeters, about 2 feet long. It isn't simply long, it's incredibly fast, flicking in and out as many as 150 times every minute. Picture dipping a strip of sticky tape into a jar of tiny beads over and over. Every touch lifts another layer. That's essentially how an anteater feeds. Its saliva is thick and sticky, causing ants and termites to cling instantly to the tongue. Tiny backward-facing structures called papillae help hold the insects in place as the tongue slides back into the mouth. And here's the remarkable part. The insects are swallowed whole. No chewing, no biting, no teeth required. That raises another question. If the food isn't chewed, how is it digested? The answer lies much deeper inside the body. An anteater's stomach is unusually muscular. Instead of relying on teeth to crush food before swallowing, the stomach performs much of that work during digestion. As the insects are churned inside, their hard outer shells are broken apart, allowing nutrients to be absorbed efficiently. In other words, the job normally divided between the mouth and the stomach has almost completely been transferred to the stomach alone. Once scientists looked at the entire feeding system, the mystery began to disappear. The claws replace the need to tear apart nests. The long snout reaches into narrow tunnels. The sticky tongue captures prey. The papillae prevent insects from escaping. The muscular stomach crushes what the teeth no longer do. Every missing function has already been replaced by something better suited to the anteater's lifestyle. And that leads to one of evolution's most elegant ideas. Evolution didn't remove teeth first. It built a replacement system first. Only after those new adaptations made chewing unnecessary did teeth gradually lose their advantage. Over more than 25 million years, natural selection no longer strongly favored maintaining complex teeth. As generations passed, mutations affecting tooth development were no longer removed as efficiently, a process scientists call relaxed selection. Bit by bit, teeth faded away. Not because they were harmful, because they were no longer worth keeping. Exactly which genetic changes completed that process is still an active area of research, so scientists don't yet know every step involved. The fossil record leaves gaps, partly because tropical forests are poor places for preserving fossils. But the overall story is remarkably consistent. Evolution didn't forget how to make teeth, it simply stopped needing them. And once you notice that pattern, you begin seeing it elsewhere. Anteaters aren't the only mammals that abandon teeth. Pangolins also eat ants and termites without chewing, although they are not close relatives of anteaters. Instead, they arrived at a similar solution independently, a striking example of convergent evolution, where unrelated animals evolve similar adaptations because they face similar challenges. Baleen whales followed a different path. Rather than catching insects, they filter enormous numbers of tiny marine animals from seawater using flexible plates of baleen instead of teeth. Different ancestors, different environments, different solutions, yet all reached the same surprising destination: life without teeth. That reveals something profound about evolution. It doesn't work toward complexity for its own sake. It works toward efficiency. If a body part continues helping an animal survive and reproduce, it's likely to stay. If another system performs the same job more effectively, the original feature may slowly disappear over countless generations. The anteater's empty mouth isn't evidence that something is missing. It's evidence that everything else became so specialized that teeth were no longer necessary. So the next time you see an anteater stretching its impossibly long tongue into a termite mound, remember that you're looking at millions of years of refinement. What seems like a missing ability is actually one of nature's most successful redesigns. A reminder that sometimes the greatest innovation isn't adding something new, but letting go of what you no longer need. If you enjoy uncovering the science behind everyday mysteries, subscribe to Curio Logic. There's always another ordinary wonder waiting to be seen in a completely new way.